Welcome to the deep dive. You are exactly where you need to be if you're looking to get smart, fast, and really thoroughly about the figures who didn't just participate in the digital world, but who fundamentally engineered its foundation.
We're here to give you that shortcut to being truly well-informed, moving beyond the legend and into the deeply critical details.
Today, we are undertaking a pretty critical synthesis of the sources you shared on one of the most influential, yet, personally contradictory figures in modern technology, Linus Torvalds.
His name is, well, it's synonymous with global infrastructure, whether you're using an Android phone, a massive cloud server, or really almost anything running the modern internet.
That's right. We are diving deep into Linus Torvalds, the creator and lead developer of the Linux kernel, and of course that foundational distributed version control system, Git.
And our mission today is to understand not just the code he wrote, but the personality that curated a global collaborative revolution. We're going to trace his journey from a hobbyist coder in Finland all the way to the ultimate global authority on the kernel.
We'll be synthesizing your sources to illuminate his early life, the kind of messy, frustrating origins of both Linux and Git, and the specific high-level nature of his authority as the benevolent dictator.
And of course, we have to talk about the highly publicized, sometimes explosive controversies surrounding his leadership and his communication style.
Okay, so let's unpack this with a few startling hooks right up front that should, I think, immediately illustrate the complexity we're dealing with here.
Let's do it.
First, just consider the name Linux. He originally wanted to call his kernel Freaks.
Yeah, F-R-E-X-S.
Which, thankfully was overruled by a university server admin. Can you imagine booting up your supercomputer with Freaks? It just doesn't sound right.
It really doesn't. And then if you look at his two world-changing contributions, Linux and Git 1 was created to fill a personal technical need, sure.
Right.
But the other one, Git, was created out of pure frustration and you could almost say spite towards a proprietary vendor.
So the tool that powers nearly all modern software collaboration is basically a technical middle finger he created himself.
It absolutely is. He needed a tool. The one he was using was taken away, so he just said, fine, I'll build a better one.
And here's the detail that I think just perfectly bridges the immense scale of his work with the intimacy of his life. Deep inside the Linux kernel, way down in the core function for restarting the computer.
The reboot system call?
Exactly. There's a set of magic values written in hexadecimal. And these magic values, if you convert them, are the dates of birth of his 3 daughters.
That juxtaposition, the global operating system architect embedding a family secret into the core system calls, that perfectly encapsulates the complex, human, and technically brilliant figure we're about to explore.
I agree. Let's start at the source. Let's trace the roots of this accidental revolutionary in section 1. So to really understand how Linus Torvalds became the person who could, start a global technology movement from a university project, we have to look at where he came from.
You absolutely do.
He was born in Helsinki, Finland in 1969. And his family background, I think it sets a fascinating precedent for his later open source kind of anti-establishment ethos.
Indeed. His parents, Anna and Nils Torvalds, were both journalists, and they were notably described as campus radicals during the countercultural movements of the 1960s.
And that's not just a biographical footnote, is it?
No, not at all. It provides a context of, intellectual curiosity and a real willingness to challenge established structures. And that mirrors the open source movement itself.
Exactly. And beyond that intellectual background, there's a cultural layer here, too. The family belongs to the Swedish-speaking minority in Finland.
Right, which is a significant detail. That minority status often comes with a distinct cultural identity within the broader Finnish context. It can sometimes foster an early sense of standing, slightly outside the mainstream.
And we can't overlook the wonderful story behind his name. He is Linus Benedict Torvalds, and the sources confirm he was named after the Nobel Prize-winning chemist Linus Pauling.
But, of course, when discussing his name, he gave a much more layered, much more Linus perspective on it.
He did. He famously articulated this dual identity, stating he believed he was named equally for Linus the Peanuts cartoon character.
Which meant he saw himself as, and this is a quote, half Nobel Prize-winning chemist and half blanket-carrying cartoon character.
That quote is just pure gold. It completely humanizes him, and it sets the tone for his professional persona.
It really does. He brings this scientific rigor, that's the Nobel chemist part, but with a pragmatic, almost comforting simplicity and, a need for security. That's the blanket-carrying Peanuts character.
He wanted something robust, but also simple and accessible. Okay, so now let's talk about the spark, the actual computing. His interest began exceptionally young, age 11 in 1981, when he first got his hands on a Commodore VIC-20.
And you have to remember, this wasn't some powerful research machine. It was a consumer hobbyist device. And this was at a time when computers were still pretty rare in Finland.
Right, and what stands out here is his technical trajectory. He didn't just, dabble in BASIC like most of us did.
No, he demonstrated an immediate and, frankly, intense desire to master the machine at its most fundamental level. He quickly progressed from BASIC to programming by directly accessing the 6502 CPU in machine code.
Wait, let's pause on that for a second for our listeners. Why is that so significant? Bypassing assembly language and going straight to machine code on the 6502.
It's massively significant. Assembly language is, it's the human-readable intermediary layer between a programming language like C and the raw binary instructions the chip executes.
So that's like a translation layer.
Exactly. By skipping that and going straight to machine code raw binary or hexadecimal instructions, he was demonstrating a foundational commitment to absolute control over the hardware. He wasn't relying on a compiler or an assembler to interpret his intentions.
He was telling the CPU exactly what to do.
Directly. This meticulous, low-level mastery is precisely the mindset you need to build a modern kernel, which is the layer that mediates between all the software and the raw hardware. He was basically teaching himself kernel development by the age of 12.
And that early self-teaching was fueled by necessity, too. When he later acquired a Sinclair QL computer, he modified it extensively, especially his operating system.
That's because, as he noted, software was incredibly difficult to get in Finland in the 1980s. You couldn't just download a tool chain or, pop down to a huge computer store.
So this isolation, rather than stifling him, it actually forced him into self-reliance.
It really did. He wrote his own assembler, his own graphics libraries for Pac-Man, and even a full Pac-Man clone game he called Cool Man.
So he was building the entire software stack he needed, from the tool to translate the code to the actual entertainment at the end, all because the external market just wasn't there for him.
Which strongly foreshadows the mentality that later drove him to create Linux. If the tools you need don't exist, or if they're proprietary and limiting, you build them yourself, and you make them open.
That self-reliance theme is so strong. After graduating high school, he attended the University of Helsinki starting in 1988, but his studies were interrupted.
Right, by Finland's system of mandatory military service.
He completed an 11-month tour of duty in the Finnish Navy Island Brigade in 1989. And he went through officer training, achieving the rank of second lieutenant, serving as an artillery observer.
It's certainly a surprising line on the resume of the world's most famous coder.
It is, but you have to wonder if that kind of mandatory service instills a certain kind of disciplined, structured approach.
It very well could, even if it seems antithetical to the, chaotic, free nature of open source coding. And when he returned to his studies in 1990, the technical environment at the university was richer, and that structure was immediately applied to his most important discovery, Unix.
He first encountered Unix on a DC microvax running Ultra-IX. So this was his first exposure to a truly robust multi-user operating system, the professional standard.
It was the blueprint, but the truly transformative catalyst, that came on academic work. Andrew Tannenbaum's book, Operating Systems, Design and Implementation.
Which described MIX.
Exactly, a stripped-down educational version of Unix. Torvalds studied this, and he saw both its brilliance and its limitations, especially what applied to the hardware he was just about to buy.
Which brings us to the single most important purchase in the history of his career. January 5, 1991. He bought an Intel 80386-based IBM PC clone.
And this timing is so crucial. The 386 chip offered a 32-bit architecture and, importantly, memory management that previous chips just couldn't provide affordably. This was powerful, affordable new hardware that could handle a real operating system, not just a toy OS.
And the key detail is that he bought this PC before he even received a copy of MIX.
Yes. Having the platform was the final trigger. It enabled him to begin work almost immediately on what would become the Linux kernel.
He had the hardware, the educational blueprint in MIX, and the foundational knowledge from his 6502 days. The accidental revolutionary was ready.
So the creation of the Linux kernel was, at its heart, fundamentally pragmatic. Torvalds appreciated MIX, but it was really designed for teaching, It wasn't designed for leveraging the powerful 386 architecture he had just bought.
Right. He needed a true multitasking system that could access all the 386's features, which was something MNAX by design just couldn't easily offer.
So the core story isn't about lofty ideals just yet. It's about pure personal technical need. He wanted to use his machine fully, and the existing options felt restrictive.
And this is where that famous naming mishap occurred. Because Torvalds had a perfectly fine, if slightly bizarre, name for his initial prototypes.
The name was Freaks, combining free, freak, and the X to signify its Unix-like nature.
I can see why he liked it, but thankfully, his friend Ari Lemke, who was the administrator of the university FTP server, had much better branding sense.
Lemke unilaterally rejected Freaks. He just created a directory called Linux on the FTP server for Torvalds files. Torvalds apparently initially resisted it, preferring his own creation.
But the name just stuck.
It stuck immediately with the small but growing community of early adopters. That first public release happened in late 1991, right from that university FTP server. And version 1.0 was officially released on March 14, 1994, which really marked the kernel's stable entry into the computing world.
Okay, so the kernel's technical birth was crucial, but its longevity and, its incredible spread were entirely dependent on a legal and philosophical choice.
The crucial shift to open source.
Exactly. Initially, Torvalds used a license that explicitly forbade commercial use.
And that initial restriction was a massive limiter. I mean, it almost choked the project in the cradle. It meant that while hackers and hobbyists could use it, no company could build a business around it or contribute significantly without violating the terms.
Which raises the big question. What forced him to change this fundamental legal stance?
The sources are very clear on this. The influence of the GNU project and its leader, Richard Stallman. Torvalds heard Stallman speak in the autumn of 1991.
And that exposure, coupled with pressure from early contributors who wanted to see the kernel adopted more widely, that's what pushed him toward liberalization.
This shift to the GNU General Public License version 2, the GPL v2, was revolutionary. We really need to spend a moment clarifying why this licensing change was arguably as important as the code itself.
Yeah, let's define that. How does this concept of copyleft under GPL v2 fundamentally differ from his original, more restrictive license?
Well, his original license was restrictive. You can use it, but you can't make money from it. GPL v2 said the complete opposite. You can use it, you can modify it, and crucially, you can sell it. You can build commercial distributions like Red Hat or SCSE.
Okay, but there's a catch.
There's a big catch. However, if you distribute the modified code, you must also distribute the source code for your modifications under the exact same GPL v2 license.
So it's a feedback loop.
It's a mandatory feedback loop. This mechanism ensures that as companies leverage Linux for commercial gain, they are legally compelled to contribute their improvements back to the community. It prevents proprietary forks and ensures the collective knowledge base always grows.
So the GPL v2 wasn't just a permissive license, it was an aggressively protective one. It forced collaboration and really cemented Linux as a truly collective, self-improving project.
Yeah.
That legal framework was the engine of its expansion.
Exactly. It ensured that every corporate investment in Linux ultimately benefited the shared resource. And as the kernel grew, so did Torvalds' stature. And that eventually took him from academic life in Helsinki to professional life in the United States.
He took a job at the chip design company Transmeta in California, and he worked there from February 1997 to June 2003.
And that move was significant because it provided stability and a practical context for his work. He wasn't just a professor or a student anymore. He was an engineer working on real hardware and real architecture, which, fed directly back into his kernel understanding.
And that stability eventually led to massive, albeit symbolic, financial recognition.
Yeah.
In 1999, two major players in the emerging Linux commercial ecosystem, Red Hat and VA Linux.
Right.
They decided to reward his foundational creation by granting him stock options.
And when both of those companies went public, those options matured, and Torvalds' share value briefly peaked at about $20 million US.
It's such a powerful moment in the history of open source.
It completely validated the model. It showed that building foundational, free infrastructure could paradoxically generate immense wealth, not necessarily for the creator directly, but certainly in the surrounding ecosystem.
And Torvalds, having achieved that financial independence, was able to transition into a role that was dedicated entirely to curation.
Right. After Transmeta, he moved to the Open Source Development Labs, or OSDL, which eventually merged to become the Linux Foundation. And today, the Linux Foundation sponsors him to work full-time, exclusively on the kernel.
Which is the ultimate job description. Benevolent dictator funded by the global industry to keep the trains running on time.
And we can't forget the face of the project, Tux the penguin. Torvalds' personal mascot became the community's universal standard.
And while his ideals are rooted in open source, his philosophy remains profoundly practical. He believes open source is the only right way to do software, which, sounds like pure idealism.
But he tempers that with immense pragmatism. He's admitted to using proprietary software when it's necessary, stating that he prefers to use the best tool for the job.
And that flexibility idealism, tempered by efficiency, is just so critical to his success. It's why Linux works in so many environments, even those run by commercially focused vendors.
And that blend of technical excellence and revolutionary impact was recognized very early on. In 1999, he was included in the MIT Technology Review's TR100 as one of the world's top 100 innovators under 35.
It was such a swift journey. From a hobbyist modifying his Sinclair QL in isolation to being recognized as a major global tech force. So when we talk about Linus Torvalds today, the conversation isn't really about how much code he personally writes anymore. It's about the sheer weight of his authority.
Exactly. This is the architect who became the curator.
The sources from around 2006 suggested he wrote about 2% of the Linux kernel code. And while that sounds, numerically small in a project with millions of lines of code,
it was still one of the largest single percentages from any one person. But you're right. The point is that percentage is largely irrelevant now.
So if he's not coding the newest drivers or the latest features, what is his full-time job at the Linux Foundation? What does he do all day?
As he himself has explained, his current function is almost entirely merging code written by others. Think of the kernel as a massive river fed by thousands and thousands of tributaries. Torvalds sits at the delta.
And he decides which tributaries are pure enough, powerful enough, and safe enough to flow into the mainstream.
Exactly. He retains the absolute highest authority to decide which new code, submitted from anywhere in the world, gets incorporated into the standard, stable Linux kernel. He is the technical and, in some ways, the moral gatekeeper.
And holding that technical authority is crucial, but he also has to manage the legal authority behind the brand.
That's right. Because the code is open source and free, the brand itself needs protection. Torvalds acquired the Linux trademark way back in 1994, and he monitors its use through the Linux Mark Institute.
And that's a common and necessary protection for these big open source projects, right?
It is. Without trademark protection, any company could just slap the name Linux on a product, fork the code, make proprietary changes, and confuse the entire market. The trademark ensures quality control and brand integrity, even if the source code itself is public.
This tension between open access and necessary control is a theme that runs throughout his career, and it directly led to his second world-changing creation, Git.
The creation of Git is just a fantastic example of Torvalds solving a global problem born purely out of ideological frustration. For years, the Linux kernel development relied on a proprietary distributed version control system called BitKeeper.
And let's be clear, why was using proprietary software such a flashpoint of conflict for projects founded on open source principles?
Well, for many in the open source community, paying for or even just relying on a closed source tool for kernel management was seen as hypocritical. It went against the whole ethos.
So Torvalds was criticized heavily for this.
Heavily, but he argued that the tool was just superior and necessary for managing the scale of the kernel. However, the whole thing came to a head when the BitKeeper developers revoked the free-of-charge license for the community users.
And suddenly, the ideological conflict became a technical disaster. They were left without a tool.
And Torvalds' response to this crisis wasn't to go look for another tool. It was to build one fast.
He was driven by pure technical impatience and, I guess, ideological commitment.
Absolutely. He began development on Git on April 3rd, 2005. He wanted something that was distributed, incredibly fast and simple. And the results, they speak for themselves. Git has become the globally dominant distributed version control system.
It's indispensable for pretty much every modern software project, whether it's open or closed source.
It's a remarkable legacy. Creating a foundational operating system and the foundational tool used to manage all large software projects.
Beyond these two giants, though, he still codes for fun. His interest in scuba diving led to the creation of the Subsurface software.
Right. Subsurface is a free and open source log and planner for scuba dives, which he started developing in late 2011, licensed under the same GPL v2. He's an active diver, and this just reflects that pragmatic engineering spirit.
If you need a specialized tool, build it and make it available for the community.
And he also created Sparse, which is a highly specialized tool for kernel development itself.
What does that do?
Sparse is a static analysis tool. Its purpose is to act as a safety net. It flags specific, very complex constructs that are relevant to kernel developers, for instance, mixing pointers to user and kernel address spaces.
So these are the kinds of obscure, low-level errors that could destabilize an entire operating system.
Exactly. And Sparse helps the curators maintain stability.
Okay, let's pivot to the deeply personal details that are permanently woven into the Linux kernel's fabric. He met his wife, Tove, who was a 6-time Finnish national karate champion at the University of Helsinki.
And the story is wonderful. Torvalds was running an introduction to computer lab exercise, and he instructed the students to send him an email as a test.
And Tove responded, but instead of submitting the required test material, she
simply asked him out on a date.
That's fantastic. They married and have 3 daughters, 2 of whom were born after they moved to the U.S.
And we have to circle back to that kernel Easter egg. Explain why the reboot system call is such a unique place for this dedication.
Well, the reboot system call is one of the most low-level, critical functions in the entire operating system. It's what signals the machine to shut down and restart. Only the highest level code can execute this safely.
So by embedding the hexadecimal versions of his daughter's birthdays into this function as magic values, he created a permanent, personal, coded dedication hidden deep in the operating system's bedrock.
It's a signature mark of the creator. It's a way of merging his technical architecture with his family life, which only those who study the source code at that low level would ever find.
Following his move to the U.S., the family relocated from Silicon Valley to Duntop near Portland, Oregon in 2004.
And that was to be closer to the OSDL headquarters in Beaverton. And then a major shift occurred in 2010.
He became a naturalized United States citizen. But what's crucial here is his political statement regarding that transition. He registered as unaffiliated with any U.S. political party.
And his reasoning was that he had too much personal pride to associate with any of them.
That sentiment, that aversion to entrenched ideological groups, feeds directly into his outspoken views on religion, too.
Absolutely. He describes himself as completely a religious atheist. And his reasoning isn't just a simple rejection of faith.
No, it's a preference for intellectual honesty and technical appreciation. He feels that religion detracts from the appreciation of nature and morals because it gives people an easy out to call creation merely miraculous.
Instead of appreciating the scientific and cosmic, incredible that something like this could have happened in the first place.
Right, and he also contrasted the cultural difference between Europe and the U.S., noting that in Europe, religion tends to be personal, while in the U.S., it is heavily politicized.
And this desire for efficiency, for intellectual rigor, and this aversion to politicized conflict, all of that is central to his leadership style.
Which is the focus of our next section. This intellectual frankness and political independence really set the stage for the controversial manner in which he manages the global Linux community.
So if Section 3 defined Torvalds as the benevolent dictator, then Section 4, I think, reveals the inherent fragility of that model.
I think you're right.
Because Torvalds is just as famous for his technical genius as he is for his notoriously blunt, often profanity-laden communication style on the Linux kernel mailing list.
The kernel mailing list, the LKML, is the central nervous system of the entire project. All major decisions and code reviews happen there in public. And historically, Torvalds has used it as a platform for scorched earth's critique.
He doesn't pull punches. And he frequently uses highly charged language to dress down developers whose code he finds subpar.
Which raises a massive philosophical tension. Does that high standard, enforced by this relentless, brutal honesty, does it drive away talented people? Or is it necessary to maintain the technical integrity of a massive, mission-critical project?
That is the core debate. And Torvalds' own self-assessment is incredibly revealing. He once called himself a really unpleasant person.
And he expressed a sense of resignation about his own conduct. He stated, and I'm quoting from the source here, "I'd like to be a nice person and curse less and encourage people to grow rather than telling them they are idiots. I'm sorry I tried. It's just not in me."
So he saw his abrasive style as just an unchangeable part of his engineering personality.
He did, but this attitude created a hostile environment that critics argued was exclusive and damaging to the project's diversity and growth.
And this criticism was voiced publicly by some very respected figures in the community, people like Intel programmer Sage Sharp and the prominent system developer Lennart Poetry.
They pointed out that while Torvalds' technical judgment might be flawless, his delivery created toxic work conditions, especially for new or marginalized contributors. And this internal friction finally erupted into a major institutional reform in 2018.
The change was dramatic and sudden. On Sunday, September 16, 2018, the Linux kernel's official governance document, the Code of Conflict, was abruptly replaced.
Replaced by a brand new code of conduct, which was based on the more community-friendly contributor covenant.
This was a colossal ideological shift. The original Code of Conflict was known for emphasizing technical merit above all else, including interpersonal politeness.
Right, it essentially justified the aggressive, blunt communication style as necessary for technical rigor.
Whereas the new Code of Conduct shifted the focus entirely toward inclusion, respect, and harassment-free communication. It mirrored a major trend that was happening across the broader open source community.
And what followed that institutional change was an equally shocking personal reckoning from the benevolent dictator himself.
Torvalds issued a major public apology in the release notes for Linux 4.19-RC4. He acknowledged that his behavior had been unprofessional and uncalled for.
And crucially, he then announced he was taking a time off to seek assistance on how to understand people's emotions and respond appropriately.
This was an unprecedented admission of failure and a commitment to personal reform from a figure who had resisted that kind of pressure for decades.
That level of public introspection and institutional change just doesn't happen in a vacuum, though. The sources suggest there was an external pressure point that triggered this swift action.
Right. The events followed. The New Yorker magazine approaching him with a series of pointed, critical questions about his history of abrasive conduct.
So the timing strongly suggests that the prospect of a high-profile, critical journalistic examination played a significant role in forcing both the apology and the governance shift.
He did return to maintaining the kernel after the 4.19 release, but the Code of Conduct remains in force.
It does.
Okay, let's move to some of the high-profile public controversies that really cemented his reputation for being uncompromising. The NVIDIA incident from 2012 is a perfect case study.
This happened during a talk at Aalto University in Finland. Torvalds was asked about NVIDIA's extremely poor support for their hardware within the kernel ecosystem, which was a common headache for developers at the time.
And his response was visceral.
To say the least. He held up his middle finger to the camera and used profanity, publicly criticizing NVIDIA as the single worst company he had ever dealt with regarding kernel development.
It was a visual and verbal explosion of frustration. It demonstrated his willingness to publicly shame a massive corporation if he felt they were hindering the progress of the open source community.
It was the curator defending his garden.
And that willingness to draw hard lines was tested again very recently in a much messier geopolitical context.
In 2024, amidst the ongoing conflict stemming from the Russian invasion of Ukraine, an issue arose regarding the exclusion of some developers from the kernel maintainer list.
Right. The report suggested some developers were excluded potentially because they were Russian or were using Russian email addresses. And this instantly creates tension because open source is supposed to be borderless.
Exactly. So how does a figure who champions open collaboration justify such an exclusionary move?
This moves beyond technical merit and squarely into legal compliance, which is a new and challenging pressure point for Torvalds.
He claimed the exclusion was due to government compliance requirements and due to legal issues around Russia.
Which makes sense. If he is sponsored by the Linux Foundation, a U.S. entity, and he's a U.S. citizen, he would be directly exposed to U.S. sanctions and legal obligations.
Exactly. Even though the kernel code is free and open, the act of managing and merging code can be deemed a form of transaction or service under international sanction regimes.
So Torvalds, operating as the final authority, has to ensure his activities and those of the Linux Foundation do not violate international law. He's forced to confront the messy reality that open source collaboration is not immune to geopolitical conflict.
And he added a very personal defense to that action, too.
He did. Referencing his Finnish heritage, a nation with a complex and often hostile history with Russia, he added, "I'm Finnish. Did you think I'd be supporting Russian aggression?"
Which just highlights the immense difficulty of maintaining a neutral technical dictatorship when global events force you to take a side based on legal obligations and, personal history.
The curator is now dealing with international law, not just C code.
The entire narrative of Linus Torvalds is defined by this contradiction. A man whose open source idealism built the framework for modern collaboration yet whose uncompromising conduct necessitated a major internal reform, only to be later forced by geopolitical realities to make these difficult exclusions.
So, despite the internal friction and the external controversy surrounding his conduct, the sheer scale of Torvalds' technical and systemic contribution has earned him massive, high-level international recognition.
Awards that are often referred to as the Nobels of Technology.
Let's start with the big one, the Millennium Technology Prize.
Absolutely. In 2012, Torvalds was named one of the winners of this prestigious prize. It's often compared to the Nobel Prize in terms of its technological impact and significance.
And the award specifically recognized his creation of a new open-source operating system, leading to the widely used Linux kernel.
Right. It acknowledged that his work wasn't just good code, but a systemic change in how software is developed and distributed globally.
And his influence is recognized across the most authoritative engineering bodies in the world.
That would be the Institute of Electrical and Electronics Engineers, the IEE. He received the 2014 IE Computer Pioneer Award, which is an award that recognizes individuals whose efforts in computer science have resulted in significant and visible milestones.
And then in 2018, he received the IE Masaru Ibuka Consumer Electronics Award,
which specifically cited him for his leadership of the development and proliferation of Linux.
Proliferation. That's the key word there. It acknowledges his role not just as the initial creator, but as the sustained leader who ensured its global growth.
And cementing his role in shaping the modern digital landscape, he was named one of the inaugural inductees into the Internet Hall of Fame in 2012. He was placed in the prestigious Innovators category.
So he stands alongside the figures who truly define the Internet era.
He does. And it's rare for a software engineer to achieve this level of broad cultural recognition outside of pure engineering circles. But Time magazine repeatedly recognized his influence.
They recognized him multiple times across different axes of influence. He was named one of the most influential people in the world in 2004.
And then again as one of the revolutionary heroes of the past 60 years in 2006.
Even earlier, he was ranked 17th in their 2000 Time 100, the most important people of the century poll. That early placement showed just how quickly and profoundly the industry understood the importance of Linux long before it conquered the server market.
And his legacy isn't just terrestrial either, it's literally astronomical.
That's a fun detail. Asteroid 9793 Torvalds was named after him in 1996.
And the asteroid moon, Linus, which was discovered in 2003, was also partly motivated to honor him. It's fitting that someone who created a system designed to look at the universe through computing has pieces of the universe named after him.
Finally, we have to return to his academic roots. This entire journey started at the University of Helsinki, and they have certainly recognized him.
After years of working on the kernel, he ultimately received his master's degree in computer science with a laudator grade, which is the highest possible grade. And he's received 2 honorary doctorates, one from Stockholm University and one from his alma mater, the University of Helsinki.
And the University of Helsinki gave him the ultimate permanent dedication.
They did. They named an auditorium after him, forever linking his name to the institution's physical space. And even more symbolically, his original computer. The one that started it all.
The 8386 base machine.
That very one. It's on permanent display at the Department of Computer Science. It's a museum piece showing the physical starting point of the software that redefined the world.
So what does this entire deep dive teach us when we synthesize all these elements? We've tracked his journey from a young man who bypassed assembly language because he needed total control over his hardware, learned from MINX, then built a kernel, and get out of, well, ideological necessity.
And we see a career arc defined by this relentless drive for efficiency and open access, but governed by an uncompromising personal management style. He needed that 2018 reckoning to survive as the curator.
It demonstrates that while genius can be solitary, global collaboration requires more than just technical perfection.
And his story teaches us that in the world of massive, decentralized, mission-critical software, the most valuable role is not the initial code contribution. It's the sustained, authoritative, and sometimes agonizing work of maintenance and governance. He evolved from the core coder, the creator, into the supreme authority, the curator.
The shift is the heart of his lasting legacy. His genius now lies in his decision-making framework, his ability to merge millions of lines of code from diverse, often competitive, corporate and individual sources, and ensure technical cohesion and legal compliance.
Which leads us to our final provocative thought for you to carry forward. Given that Linus Torvalds' ultimate authority today rests almost entirely in his judgment regarding which code gets merged, the power to say yes or no to the work of thousands rather than his own programming.
What does this shift from creator to curator ultimately teach us about true leadership and lasting legacy in decentralized, global collaborative projects?
Does the longevity of a project depend more on the person who sets the technical standard and maintains the final high-level integrity, or on the multitude of collaborators writing the features?
The fact that the most important person in global software maintenance hasn't written a major feature in decades tells you everything you need to know about where true power lies.
That's it for this deep dive. We hope you feel thoroughly informed and ready to appreciate the complex history embedded in every device you use and the contradictory figure who holds the keys to so much of the modern world. We'll see you next time.